What if I told you that there's a fundamental limit to how small something can be? A scale so tiny that the very concepts of space and time begin to dissolve into uncertainty. This is the Planck Scale, a realm where the known laws of physics break apart, and our best scientific theories stop making sense. What happens when we try to go smaller? What lies beyond this fundamental boundary? Let's dive into the deepest layers of reality and explore the smallest possible size in the universe. Before we understand the Planck scale, we need to appreciate what it represents. Named after Max Planck, the founder of quantum theory, the Planck scale is a set of fundamental units derived from the constants of nature. These include the speed of light, the gravitational constant, and Planck's constant. When combined in a specific way, they give us the Planck length, the Planck time, and the Planck energy, values that define the absolute limits of our universe. But what do these numbers actually mean? The Planck length is an astonishingly small 1.6 by 10 to the power of minus 35 meters. That's so tiny that even a proton is 100 quintillion times larger. It's the scale at which quantum fluctuations in space become so extreme that classical notions of geometry lose meaning. At this level, space is no longer smooth and continuous, but instead becomes a foamy, ever-changing landscape of quantum chaos. If you try to measure anything smaller than this, space itself would rebel against you. If the Planck length is the smallest unit of space, then the Planck time is the shortest meaningful duration. It's around 5.4 by 10 to the power of minus 44 seconds, a span so brief that even light, the fastest thing in the universe, can only travel a single Planck length in this time. At this time scale, the distinction between past, present, and future begins to blur. It is thought to represent the moment right after the Big Bang, when a universe was so dense and energetic that no known physics can describe it. If we could peer into this era, we might unlock the secrets of the birth of everything. The Planck energy is the energy scale at which gravity and quantum mechanics become equally strong. It's about 1.22 by 10 to the power of 19 GeV, far beyond anything achievable in particle colliders. If we could reach this energy, we'd be in a realm where both general relativity and quantum mechanics must be treated as a single, unified theory. This is where theories like quantum gravity and string theory attempt to explain what happens when the forces of the universe become one. Could this be the key to unlocking a theory of everything? If we could zoom into the Planck scale, we wouldn't see a smooth fabric of space and time. Instead, we'd encounter quantum foam, a chaotic sea of constantly appearing and disappearing virtual particles. This is where space itself becomes probabilistic, bubbling and warping unpredictably. Some theories suggest that wormholes or microscopic black holes could momentarily exist at this level, constantly fluctuating in and out of existence. Space is no longer just the backdrop of reality. It becomes a dynamic participant. One of the strangest aspects of the Planck scale is that it acts as an observational barrier. Any attempt to probe smaller distances would require so much energy that you'd end up creating a black hole instead of making measurement. In other words, trying to measure anything smaller than the Planck length results in an event horizon forming around it, cutting it off from view. This suggests that space itself may be quantized at this level, meaning it has a fundamental smallest unit, like pixels on a screen. Physicists are racing to develop a theory that can describe both gravity and quantum mechanics at the Planck scale. String theory suggests that tiny vibrating strings are the fundamental building blocks of reality, avoiding the singularities predicted by current physics. Loop quantum gravity proposes that space itself is made of discrete loops, eliminating the paradoxes of continuous spacetime. Whatever the answer, unlocking the mysteries of the Planck scale could change our understanding of the very fabric of existence. The Planck scale may be the smallest, meaningful size in our universe, But is it truly the ultimate limit? Some speculative theories suggest that reality itself could be a fractal-like structure, infinitely divisible no matter how deep we go. Others propose that beyond the Planck scale lies a deeper layer of physics, one we currently have no way of accessing. If that's the case, then the true fabric of the cosmos might be even stranger than we ever imagined. The Planck scale is one of the greatest frontiers in physics, a boundary that defines the limits of our understanding. Could a deeper theory reveal what truly lies beyond? What new mysteries will we uncover as science advances? If you enjoyed this dive into the fundamental nature of reality, be sure to like, comment, and subscribe for more deep explorations of the universe. Thanks for watching Mind Stretch.